In this video, we'll be finding the focus, the directrix, as well as the axis of symmetry and the vertex given the equation of the parabola. Now, the reason why I specifically say all of those details and the actual question specifically says find the focus and the directrix of the parabola is because, well, to find the focus and the directrix, you kind of need the vertex. You can't really do anything without the vertex. So this right here, equation of this form tells me that because I've got y squared, I know that this thing has to be facing sideways, either left or right. Another detail that's important with this is that the 2 is with that y squared, and that 2 is actually causing us a problem. I need to move that 2 over with the x, because remember, if you look at your formula sheet, the formula for either one of the forms of the parabolas has the squared term all by itself, and 4p with the other piece. So what I'm first going to do is I'm going to move this 1/2 over to the other side. I'm going to put y squared first. I'm going to divide by 2, 1/2 x. The next thing I'm going to do is I'm going to try and set this up in the form of, well, if you notice here, since there's nothing inside of the squared term with y and there's nothing with that x being added or subtracted, I know that my vertex is h comma k being 0 comma 0. 0 for the first term because there's nothing with x, 0 for the second term because there's nothing with y. The next detail that I'm going to go ahead and follow through with is the identification that this should be y equals to 4p times some version of x. So that means that 4p has to be equal to 1/2. Now again, there's other ways you can do this manipulatively, but I think this is algebraically the easiest way to see it and then be able to follow through. So for me to find p, I'm just simply going to go ahead and divide both sides by 4, giving me 1/8. So that means that my actual equation, this thing right here, is going to be turned into y squared equals 4 times 1/8 times x. So this being the p value tells me I know how far I have to shift forward or backwards in order to get the focus or the directrix. So again, it helps sometimes to draw what you have. I know that my vertex is at 0, 0. I know that my focus is supposed to go 1/8 of a unit in the x direction. Now keep in mind that 1/8 is, you're adding this 1/8 to the x value of the vertex. So if this is 1, 1/8 is somewhere right about here, give or take. And then my directrix should be about right there on the other side of it. And then this thing should be going like this, more or less. So with this being identified, and again, the idea of how this is going to be set up, I'm going to go ahead now through the formulas of plugging this stuff in. Again, I know that the graph is facing this way because my y term is the squared term. If it was x squared, I'd go with my normal understanding of a quadratic graph. So with this being done, I'm going to go ahead and find my focus first. Again, my focus is simply taking that 1/8 value and adding it to the vertex value of which the variable it sits with. So it sits with the x, so I'm going to add it to the x value of the vertex. So I'm going to have 1/8 plus 0, which is simply 1/8 comma 0. That's my focus. There's the first piece it asked for. In terms of the directrix again is an equation of a line. That line has to be, in this case, x equals, because again the p value sits with the x. So x should be equal to, and again it's the vertex value 0 minus the p value being 1/8. So it's 0 minus that value, so it's negative 1/8. And again, it is the equation of a line, so it must be x equals. It can't just be negative 1/8. It can't just be a point or anything. It has to be the equation x equals negative 1/8. The last piece that I'm going to go ahead and identify is the axis of symmetry, just so that, again, if the question comes up later, you know how to do this. Keep in mind that the axis of symmetry for this one is perpendicular to the directrix, so it has to be a y equals line. And it's simply the y equals the value of the y value of the vertex. So y equals 0 is that axis of symmetry, if you were asked. So this is how you find all the details of the information. Again, it's a matter of first rewriting the equation in the form something squared equals 4p times the thing that's not squared, and then just tearing things apart, identifying what the p value is, the distance between the vertex, either x if it's y squared or y if it's x squared, and then you're just going to go ahead and add or subtract where necessary. With that being said, let's go ahead and move on to the next question. The next question is a little bit more difficult. 8b provides you with 3x plus 2y squared plus 8y minus 4 equals to 0. Now the problem with this one is the fact that it's not in any form of something squared with parentheses around it equals to 4p times x. What you do notice, however, is that there is a y squared term. So knowing that there is a y squared term tells you that that's the term that's going to actually have the overall squared information. Again, so that means that I know I need to get it into y minus k quantity squared equals 4p times x minus h. This is the form I have to get it into. So that means I'm going to go through the steps of first getting it into, well, a number times x minus h and y minus k squared. For me to do this, I'm going to have to go ahead and backtrack to some understanding of previous content. I'm first going to subtract the 3x from both sides. I'm also going to add the 4 to both sides. This will allow me to get all my y terms to one side. And with all my y terms being on one side, I should then be able to find a way to make this whole thing y minus a number squared, which, if you recall, I'll divide everything by 2 here, or more appropriately, I'll multiply everything in here by 1/2, and therefore multiplying everything over here by 1/2. This will allow me to have y squared plus 4y equals 2. I'll distribute this through to get negative 3/2 x plus 2, and this will probably come back later, but I'll deal with that when I get to it. This right here, if you recall, the previous content that we used to write this as something overall squared is called complete the square. So very carefully, I'll go ahead and quickly I'll do that. I'll take my 4 value, I'll divide it by divided by 2, I'll square it. That'll give me, again, 2 quantities squared, and therefore I'm going to have 4. I'm going to add 4 to this side, and in previous examples, we might have subtracted it in this exact same side. But what I'm going to do is I'm simply going to add it to this side as well. So I'm going to add it to both sides of the equation. Then I'll factor this side. This side will factor perfectly into x, the plus the 2 right there. Quantity squared equals to negative 3/2 x plus 6. So now this side right here is in the form that we need to. So I know my k value is now a negative 2. Again, notice that it's plus 2. This is supposed to be a subtraction, so this should be a minus 2 for my k value. Now over here, I need it to be 4p times x minus h. I'm going to worry about the 4p after the fact. I'm going to worry just get about x minus h by itself, which means out of this thing right here, I need to factor out a negative 3 over 2. So what I should really do is I should probably just factor that 1/2 that I multiplied in the first place. When I factor that 1/2 out, this is going to be a negative 3 x plus, and then when I factor a 1/2 out of this, notice there isn't a 1/2. So what I'll do is I'll multiply top and bottom by 2 over 2. Then I'll factor out this bottom piece, and I'll multiply this piece in. So that's going to give me 12 when it's all said and done. Again, if you multiply this back in, you'll realize that you're going to get 6 for this one, and you'll get the negative 3/2 for this one. So now I'm not done yet factoring because I do need to deal with that negative 3. That negative 3 needs to come out as well. So I'll factor out a negative 3/2 in total, changing this to be a positive x. This positive will change to a negative when factoring the negative out, and this will change to a 4. Hey, now I have y plus 2 quantity squared equals to something times x minus 4 in parentheses. With it being this form, I now have my vertex being h comma k, my h being a positive 4 because this is negative 4, and my k being a negative 2 because this is positive 2. It's very much similar to the concept of transformations. So I now have my vertex, and now I just got to find out what my focus, my directrix is, and then I'll go ahead and find the axis of symmetry. In this particular example, I'm not going to go ahead and waste the time drawing the graph. I kind of have the idea of what's supposed to be going on. I do know that this thing right here is supposed to be my 4p. So what I'm going to straight up do is just set that thing equal to 4p, and I'm going to solve for p. Sorry, that's a 2. In this case, p is going to be equal to a negative 3 divided by 8, and negative 3/8 is then the value of p. Keep in mind that that p value has to be added to the x value for my focus and then subtracted from my x value for my directrix. So my x value starts off at 4. I'm going to go ahead and do this way first. It's 4 plus the negative 3/8 comma negative 2, and then the directrix is going to be x equals, it's supposed to be the 4 minus the negative 3/8. In this case, we can go ahead and solve this outright by finding a common denominator between these two pieces and simplifying in a totality. If I'm not mistaken, finding a common denominator here is 8 times 4, which is going to be 32. 32 minus the minus 3 is going to be 29. So I'm going to have 29 on top over 8, comma, negative 2 is the focus location. And then this thing will simplify down in a very similar way, but this time I'm going to go ahead and have it adding that value. So this is going to change to, again, 32 over 8. 32 plus 3 is going to be a 35 over 8. That's what my x equals to. The axis of symmetry, don't forget, is simply just the perpendicular line to the directrix, so it's if this is y equals, this has to be, sorry, if this is x equals, this has to be y equals, and y equals, this doesn't change in any way. So my axis of symmetry is simply y equals -2. So that's how you're going to do these problems. Again, keep in mind, if it's not in this form as it is, you have to get it to this form. If you don't see parentheses squared and you see other y terms or other x terms in this problem, you have to use complete the square on the term that's squared with all of its other factors before you can find all this information.